Okay, so discrete data. If we're dealing, what is discrete data? The dots, yeah, it's when we have points. Discrete, it's points. So given this, when x is -4, what is y? -8. When x was 0, y was 0. When x was 2, y was 4. And 5, it was 10. So can you please plot these points, everybody? Plot these points on the graph. So yeah, it's a 10 by 10 grid. That helps you. So -4 and then 2 from the bottom to get -8. 0, 0.
Have to write the numbers on the graph.
Nope. 2, 4. And 5 and 10. 5 and 10. Okay. Now with discrete data, when given points are given to you, do you need to connect the dots? No. No. Eric, take that out. Thank you. No, we don't connect the points with discrete data. How do we write the domain when it's discrete data? What's the domain? Location of the x's. -4, comma 0. Here's our domain, right? Here's our range. So 2 and 5. Range values would be -8, comma 0, comma 4, comma 10. Okay? So that's discrete data. Let's delete this. The next question is a linear equation. Now, how do we know it's linear? Do you see the equation right here? Y equals 2x plus 3. Because it has degree 1. Degree 1. The x and y are to the power of 1. So degree 1. So how did we solve these before? How did we graph equations? Now let's change our table of values. We choose any x. I'm going to change our x values because I don't like these ones to -2, -1, 0, 1, 2. Simple, short, sweet. You should make at least, when you make a table value, at least 4 or 5 values when graphing. Okay, so your homework yesterday, you had to graph. So now that we know we have some particular x's, how do we get their y's? Plug it into the formula. So 2 times, we're using our formula, x equals -2 plus 3. What's 2 times -2? -4 plus 3 equals -1. So when x is -2, I'm going to darken my axis. Mine is not very clear. So when x is -2, y is -1. Here's 1 point. So we just keep plugging it in. Now when x is -1, we plug it into our formula. 2 times -2 plus 3. What does that equal? 1. So at x is -1, y is 1. 0. 2 times 0 plus 3. 3. So 0 and 3. Okay, keep going. 2 times 1 plus 3 equals 5. So 1 and 5. X is 1, y is 5. And then last, when x is 2, 2 times 2 plus 3 is 7. So 2 and 7. Now, when we have an equation, do we join the dots? We have y equals. Yes, all equations, we join it, unless they tell us there's restrictions. So here, y equals 2x plus 3. I'm going to grab a ruler, or you can use the edge of your calculator to help you. We're going to draw a line to connect them. There you go. Right through. Okay, so we want it to go through all our points. Just fix this a little bit. Oh, there we go. Okay, there's our line. Now, in a linear, all lines, as long as there's no restrictions, there's no dots, so it's point beginning and end. What is our domain? Will it go forever to the left and to the right? Will it keep going both directions? Yeah, it's going to keep going and keep going. So it's x is an element of the reals. Will it keep going up and down for range? Yeah, YER. How do we get a rate of change? What over what? Rise over run. Remember, we always pick a point. Doesn't matter where we start. No. Let's start at 0 and 3. Let's go to the next point. So I have to go up how much? Up 2, and then right 1. We're making like a triangle. So we had to go rise over run. We had to go up 2, right 1. 2 over 1. And what's 2 divided by 1? 2. 2. What do you notice about our rise over our rate of change and our equation? The number in front of x is always your slope or your rate of change. Yeah, so 2 is our rate of change. It's the number in front of x. And what do we know about the plus 3? What makes the plus 3 special?
That's the rise.
Which intercept? It's the y-intercept. It's the initial amount, the y-intercept. When x is 0, y was 3. Right? This right here is our y-intercept of 3. And so that's what this 3 is always. It's your y-intercept. When x is 0, y is 3. Then it's not linear, and then there's not a constant rate of change. So this only works for degree 1 equations. Okay? All right, so what I'm going to show you something on your calculator. How do we make life a little bit easier? If you go to their next page, does everyone have this down?
Yeah.
Okay. Oops, delete this. Okay, so on your graphing calculators, can we just change our table here? Now, does it matter which x values we choose when we make a graph? Could we choose any x values? Yeah, you can choose any x and then solve for its y. It doesn't matter what you choose when you're making your own graph. I like to stick to -2 to 2. Simple, short, sweet, small numbers, easy to solve. Now your graphing calculator can help you. How? Well, you're going to push the y equals button, and then you're going to type in your equation. What's my equation for this line? 3. Where's the x button? It's this one, x t alpha n. That button is your x. It's the easiest way to get to x. And then plus 2. And then we're going to push graph. Okay, so in your graphing calculators, it's going to be magic, yes. Y equals, we're going to type it in, 3x plus 2. 3x plus 2. So we're going to have that in. Now, you have to have equation in for it to do anything. If you don't type in an equation, how could it read your mind and know it's a graph? Just can't.
That would be awesome.
Yes, but that doesn't exist just yet. So 3x plus 2. That's our equation. So how do we see what the graph looks like? Graph. That's what our graph is going to look like. Now that doesn't really help us with actual points. So we want to make a nice graph. So where do you think we're going to go to get to the table?
So you go second graph.
Second graph. Kramer has all the answers. Okay, so to find, we want a table of values. So second graph is what we want to push to get our table of values. So you first always have to type in your equation in y equals, and then we can go to second graph. Everything to do with graphing are these top buttons. It's either going to be the blue button, or some of yours, I think. Is everyone's blue? Gray. Some of yours gray? Or these yellow ones, so the second button. Yes, Scott. Yeah? Yeah, that's true. So I'm just trying to keep it simple right now, but if you figured that out, great. Okay, so second graph, there's your table of values. And you can use the up arrow and the down arrow to scroll through different values. And there it is. So when x was -2, what's y? Okay, so if you don't have anything there, Julia, okay, it's -4. When x was -1, y was -1, 0 was 2, 1 was 5, and then 8. So you won't have anything here if you don't have anything in y equals. Now to get out, the clear button doesn't work. You have two options. You could either push the graph button to get out of here, or quit, second mode, quits out, second mode. Or you could just push the graph button and that will take it out, graph, and then clear. I think it'll still keep you there. No? Okay. All right, so second graph gives you a table of values. Now can we plot those values? Yes. So let's plot them. When x was -2, y was -4. When x was -1, y was -1, 0, 2, 1, and 5, 3, and 8. Do we connect the points? Why? Not because it's linear. It's, what is this? An equation. Whenever we have an equation, if you can actually type this into your calculator, you're connecting it. Does it connect on your calculator? Yeah, is it continuous there? Yeah, so we're making ours continuous. Okay, so draw your line. So blue. Actually, undo. This way. Just fix this. Okay, so question. Domain. Domain. Forever left and right, keeps going left and right, so there's no restrictions on x. X is an element of the reals. Will it go forever up and down? Yes, there's no restrictions on y, so y-er. The rate of change is rise over run. So to get from one point to another, if I start here, I have to go up how much? Everyone with me? Rate of change, rise over run. Go up how much? 3, right, 1. And is that a coincidence that it's 3? No. The number in front of x is your rate of change. Where did the 2 come from? The y-intercept. 0, 2. The y-intercept is 2. Okay, so we're going to get a lot of practice next unit on all this stuff. Okay, now try the next one on your own, please. I'd like you to make the table of values and graph it. Okay, here with your graphing calculator, so you should have taken your calculator, go y equals, push clear to clear that graph, and then push x squared. Y equals x squared. If you graph it, this is what our graph should end up looking like. Why do we expect it to not be a line? Degree isn't 1, it's degree 2, it's a quadratic. So second graph will give me my table of values. When x is -3, y is 9. Does that make sense? Does -3 squared equal +9? Yeah. So 4, 1, 0, 1, 4, 9. Excuse me. Why not?
I put -3 squared and it put 9, but I put -3.
If you're subbing it in yourself, you always have to put x in brackets when you sub. If you don't, what's happening is, remember this from radicals unit, it's just squaring the 3 and not, it's just doing -1 times 3 times 3. Okay? Okay, so -3 is equal to +9. Oh, that's not right. And +3 was equal to 9. Guys, -2 was 4, +2 was 4, -1. So plotting our points, we're plotting all these points. Shouldn't. This is your table of values. Okay? Something's plotted wrong then.
I put them on the bottom instead of like this.
Oh. Okay, so question. Yes, we should connect. Why should we connect these values? Guys? Jeremy, just wait, please. And Danny. Why do you have to connect the data? It's an equation. Okay? Now, first question, first thing I want to ask you or talk to you about is that all quadratics or degree 2s are called parabolas. Another name for them is a parabola. Parabolas always make this shape, either up or down or sideways, right? This is the U shape. A little story for you. Jesus was out preaching to some people, and he said, "The kingdom of heaven is like 2x squared plus 3x plus 5." He said that. And Peter and Paul came upon him, and as he was preaching, and Peter said to Paul, "What is he talking about, Paul?" And so Paul said to Peter, "Oh, don't you worry. It's just another one of his parabolas." Get it? Parable, parabolas. Oh, it's good. Good. Okay. Some cheese for you today. Cheeseburger and fries. Okay. X. Domain. Why is it XER?
Because it goes on forever.
Both. Which way? Which directions? Ryan, I think you need to move. Either listen or work on math. Okay? So, does it keep going to the left and the right? Will it spread out both ways? Yes, it'll keep going left and right. So XER. Range, which is your Y value, does it go forever up and down? No. Where does it start? 0. It goes from 0 and then continues up. So we say Y is greater than or equal to 0. Y is greater than or equal to 0. And that.
If you're putting the point and like this on this side and this on this side, does it matter which side?
You can write it like this, and that's fine. It's not proper. Oh, you should technically write if it's between two values. So like here, this y is between these two values. You should write the lower than the higher. You can switch them, but then your arrow direction will switch.
Yeah.
Okay. And that's